All right, guys, so I'm smiling because at the 19-minute and 28-second mark, I got zapped. I mean, it came through the table, through the distributors, through the drill handle, and popped me. So that's why I was emphasizing these boxes with high amps are no joke. Reason it did that is because even though I had zero continuity, and you'll see the rest of the video, I did not grind all the mill scale off of that steel. And I'll show you what that looks like here. This, when they make this stuff, this is down to the bare metal. This is mill scale. It does not conduct electricity very well. So if you're going to ground to metal like this, make sure you get the scale off. So anyways, thank you for watching. Please subscribe. Enjoy the rest of the video. Have a great day. Welcome back, everybody. Brian Salter here with Salter Racing Engines, and today we're going to be talking about something that's extremely neglected on a race car and even stock cars. What is that? It is grounds. So where do we start? Well, I first of all want to implore you, okay? No, not employ you, implore you to stay and watch this whole video, okay? Please do that. Also, a lot of you watching are not subscribed. Please subscribe. Also, we got t-shirts coming out, hoodies coming out. I'll have parts and stuff coming out. I'm trying to get a website thing going. I have a website, but it has not been touched since 2011. I just let it go because we didn't need the work. So anyway, I'm trying to get some people to help me with that. So please watch the whole video. I think you're going to learn a lot. So here we go. Why are we talking about this? Well, this has one of the greatest effects on your engine performance outside of the engine itself, outside of the fuel itself. The electricity in a race car is so critical, and I find it to be extremely overlooked. Many times I get calls, hey, we're having a problem with our car, and I'll ask what it's doing, and they'll tell me the symptoms, and almost always I can go and find a ground that's not correct or too small, or they've grounded it through paint or powder coat, things like that. So today I'm going to hopefully educate you on some things. You might know most of this, you might learn some stuff, so just hang in there. Two types of voltage you deal with in automotive, and alternating current is one, direct current is another. Now, we know that we use a battery in automotive, and direct current means it starts, well, in my opinion, I teach the electron theory, and direct current starts from the ground and goes to positive. Now, there is a conventional theory, which is positive and negative, but I don't teach that, and I have a reason for it. There are times when you can use either one. So if y'all want to know about that later, just send me a bunch of comments that you want to know the differences, and I'll explain them. When do we use alternating current? See, direct current is created chemically, okay? In a battery, it's chemically created. Alternating current, however, is created by magnets. So in order to create a voltage, you must move a conductor through a magnetic field, all right? Well, that's alternating current. We have an alternator on the car, and the other alternating current is the voltage that comes out of the coil. Now, with that being said, what we're talking about right now is the ground's ignition system, and until it gets to the coil to produce a spark, you're dealing with direct current. It is the most overlooked thing are the grounds on a car. Your two symbols, you got a chassis ground, and upside down Christmas tree is a very commonly used symbol for ground. Also, the wire size on your grounds. I'd say a minimum of 6 gauge, but I prefer a 4 gauge. Critically, if I have a hot positive wire that is, let's just say even 2 gauge, then I'm going to have the same size wire on my grounds. A lot of people put large positive wires on and have rinky-dink ground wires, and the two are incompatible. If you got to flow 800 amps from a battery, you got a bottleneck with a small wire, okay? So The two wires need to match. How should we ground? Battery frame, engine block, battery, engine block, frame. This is how I teach people to do it. You can't have enough. I should be able to go to the rear bumper of that race car and go all the way to the front of the race car, front bumper, or excuse me, all the way to the negative terminal of the battery and get zero resistance. And I'm going to explain that as well. Today, I'm going to show you, I'm going to illustrate what poor grounds have, what kind of effect they have on your ignition system. And I think it's going to shock you. Get the pun? What's the causes of poor grounding? Paint, powder coat, corrosion, too small a wire, or even just loose bolts. Paint is not a conductor. Powder coat is not a conductor. What does conductor mean? It means it will allow electrons to pass through it. And none of those things will allow that. Corrosion is certainly not a conductor. Too small a wire. How is that a problem? Okay, so when you have too small a wire, imagine 1,000 cars on a 2-lane road that's a 1/4 mile long. There's just nowhere for them to go. You've got all these electrons, all this amperage trying to travel through a wire that's too small. And what will happen is the wire will get hot, and as the wire gets hotter, it actually creates more resistance. Heat creates resistance. Resistance creates heat. So then what happens? The wire melts, it catches on fire. Too small a wire is a big problem. Loose fasteners can act and simulate as if the wire is too small, just from being loose, because you have not a lot of surface contact when the fastener is loose. Now we're going to talk about, I'm going to show you here in a second with a multimeter, but we use the terminology called ohms when we test resistance. Never test ohms on anything higher than the 2K scale, 2,000 ohms, when doing troubleshooting. And you say, well, why is that? Because when you select the ohms selection on your meter, okay, some of the meters are auto-ranging. In fact, most meters are, but you can change the decimal place on them. You don't want the impedance of the meter to be higher than 2,000 because you may have a wire or whatever it is you're testing that needs to read less than 2,000 ohms, but you're pushing 1,000,000 ohms through it, of a million on the impedance scale, and actually will show a reading when it actually should not be showing a reading. So anytime you're troubleshooting wiring or grounds, do not exceed 2K ohms, because you're going to wind up getting false readings and you're thinking something's good when it's actually not. Now, the three things. We have voltage, amps, and ohms. Voltage is pressure, guys. Amps is the volume of electrons. Ohms is a unit of measure for resistance, okay? So imagine we have a garden hose, and the garden hose, hooked to our house at the faucet, and we have no sprayer on it at all. And we turn the faucet on, we have a large, say, 1-inch stream coming out of the hose, and it shoots out of the hose, I don't know, 4 feet or so, but it's a large 1-inch diameter stream. Let's consider that to be low voltage, high amperage. That volume of water is your volume of electrons, and it's a lot of them, but there's not much pressure behind it. Now let's take the same hose with the same, everything's the same, except for I put a sprayer on it, and now I have a little tiny 1/8-inch stream shooting 30 feet. I have not much volume of water, but I have high pressure. That is voltage. And the ohms is your resistance to that flow, okay? So voltage is always your pressure, amperage is always the volume, and the two always, not always, but the two will a lot of times be one way or the other. It's not often that you have super high voltage and super high amperage, because usually it's not needed. I have a 12-volt system in most of your cars, and what do you have on the amperage? 800, 1100 amp batteries, right? You can have high voltage and lower amperage. You take a taser, for example, and some of those things are 500,000 volts or 800,000 volts. I saw one advertised for 936,000 volts. Well, if that had any amperage in it, if you tase somebody with it, it would blow their eyes out of their head, and their head would probably come off their body. It would be a very nasty display of power. it has no amperage on it at all. Change that around to where you've got 500,000 amps and you'll see the voltage is low, it's going to do some damage. The amperage is the flow of electrons, the volume passing through that circuitry. Now, again, I wrote notes here. It's important to match your wires so positive and negative need to be the same wires. So with all that being said, why are we talking about that? Because I just want to kind of give you an overview of what's happening in the electrical system. I could go very in depth, and I may if people ask me to. Why are grounds important? So many people see the red and the plus sign, and they get a big wire and they tighten it down good, and then you go look at their car and check it out, and you got this little dinky ground wire, and oh man, it irks me so bad. And when you help them and their car runs like a whole different animal afterwards. And I'm going to show you why. I'm going to show you what a spark plug does when you have terrible grounds. So we're going to move over to the table here in a second, and I'm going to show you some illustrations. Okay, so here we have a snap-on multimeter, and it's called multimeter because it does a multitude of things. Today we're just talking about volts, amps, and ohms. Now, anytime you see a V with a line over it, a sine wave, that is AC, okay? Anytime you see a volt symbol with the straight line, that is DC, then you have a millivolt scale, and then what some people call the horseshoe, that is your ohms scale. And you'll notice it has a speaker symbol and a diode symbol. So we're going to be checking ohms today. Now, first of all, you always want to make sure you have a good battery in your meter, and if you don't, it usually has a little alert battery symbol come up in the window. And this is digital. The other kind of meter would be analog, which would have a needle. So, analogs, by the way, are faster than digital meters. So sometimes I will use an analog meter because I need that immediate reaction. Now, I can talk about this meter, but that's a whole course on itself, so we're just going to move on. We're on the ohms scale. We're measuring resistance of a circuit with this. Now, anytime you're checking resistance, guys, always make sure you need to know what the base reading is on your meter. So I'm going to take my two probes here and I'm going to touch them together. And so I know the lowest that this meter can go is 0.1. All right? That's the lowest it can read. So the best reading I could get out of a wire is 0.000.1. Now you see the OL, that means out of limits. Okay, so when you understand that means out of limits, it cannot read it. And right now there's nothing to read. Now, here we have a typical wire. And what I want you to see is notice that this wire end is in good shape. And notice this wire end has one strand. One little strand, okay? Out of all these multiple strands, as I've twisted these tight, so there's right many there. You got one strand left, all right? What do you think we would get if we tested resistance through that wire? And would it pass a voltage through the wire? Well, the answer is yes. If I hook this to my battery, it will, whatever the battery voltage is reading, let's say it's 12, it will read 12 volts on the other end. But remember the highway scenario with 1,000,000 cars, or was 1,000 cars with just a little quarter-mile strip of highway? You're going to bottleneck and everything's going to get hot and melt. If you tried to pass amperage through that little strand, you're going to melt it. And what I'm simulating here is to show you that when you're checking for resistance, when you're checking continuity in a circuit, ohms is not always the best thing to check. Now watch. Let's see if we get a good clip on it. You'll notice I'm not touching the multi-strand. I'm only on the tiny strand of wire that's hanging out of it, and I have perfect continuity. That means that the meter says that this circuit is in perfect condition. But you know that if I was to try and crank my car with that little wire bolted to the block, what would happen? Well, it would just melt the wire instantly and I would have nothing, but nothing would happen pushing the button or turning the key. That cannot carry a load, all right? Another example is this wire right here. Here we have a good end that's clean. All the strands are there. And now look at this side. Everybody see how black that is? We'll put it against my skin. You see the difference between the two? That is corrosion. That is corrosion that has gone up in the insulator and corroded that. If you see a wire like that, do not use it. Do not use it. That corrosion has coated the outside skin of that copper and it will prevent good connection, okay? Now, I'll just throw this in because it's right here in front of me. These are the racing spark plugs we use in NASCAR, and that's a C57CX. Excellent spark plug, by the way, if you want a recommendation. If you can use that style plug, that is a very good spark plug. Okay, we're going to pause now and go to the test stand. Okay, so we're at the little test stand that I've got set up here. And what I want you to notice is we're still got our meter here, and I've got it back on the ohms scale, checking resistance. And by the way, never check a wire like this. You see what we're getting on the meter? Okay, so you're reading about 2 million ohms passing through my body. So when you're checking a wire, make sure you're not touching the wires. And anytime you check ohms or resistance in a circuit, you have to isolate it, which means if I'm checking a wire, I have to pull that wire out of the circuit because it will backfeed through the other circuits and give you a false reading. So always isolate when you're checking resistance. Now, because I'm on a table here, I don't have a chassis ground or a frame or anything like that. So what kind of ground can I use to demonstrate this ignition system? Well, the answer is an earth ground, okay? So what I'm going to do is I've got a steel plate here, and I've got one of the connectors here on the plate, and I've got jumper cables attached to my floor plate here, all right? Now, the reason I'm using the floor plate is because sometimes I'm doing welding on a engine part or whatever, and I don't want any drippings to get on my concrete that I just had poured and mess it up. So what I'm going to show you is that because of these cables we have hooked here and to the steel plate, we are grounded perfectly. So we're going to get down here. I'm just going to click it on the steel plate, and look at there. We have perfect, I'm sure I can get it better than that. Anyways, you get the idea. It's like hardly any resistance. Maybe there we go. 0.2 of an ohm resistance. That's nothing. Remember, the perfect meter was 0.1. So between these cables going to this earth ground plate, we have 0.2 of an ohm resistance. Okay? So I wanted to show you that before we go any further. So that is going to be our ground as if we were in a car. All right, now, first thing I'm going to do is show you what a properly grounded engine should do. Here we have a cylinder head simulation that I've cut in half, and a spark plug in there. We've got a coil, and we're using MSD here. By the way, let me give you a little safety here. MSD makes multiple types of boxes. This is just a Street Fire box. It's about 5 amps or so, and I did a test on it. It draws, when you're running the car with no alternator and just on the battery, you're losing 0.5 volt draw, I think it was, from just the box. So, what I want to say is this thing can be dangerous. If you get shocked by this, you are not just getting a little pop, you are getting at least 5 amps of current passing through you. Do not ever, when you're running a race car with an MSD box, especially if it's a really high output engine and you have as much as, some of these have 40 amps and 50 amps of current, especially top fuel cars. Don't put your hands up here on top of this cap. It can knock you dead. It can stop your heart. Do not do it. Do not do it, okay? This is not the old HEI. This thing will hurt you, and it can put you in the hospital and take your life if it hits you on the right heartbeat, okay? All right, so Logan, stand over here. And what I'm going to show you is, I'm going to show you what an MSD should do. And I'm just gonna hook up a little deal here. Again, this is on this head is on the plate. The plate is grounded to the earth, and that's our ground. We are now hot, okay? I'm gonna hook this MSD up to a distributor here, to the shyster. Yep, it just barely got me here. All right. Okay, pause it. Okay, so I've got this thing grounded to the earth, and I went ahead and clipped on the head too, because I want to make sure it didn't backfeed and zap me. I'm going to put my microphone close to this so you can hear it, and you can get the really effect of what's happening here. All right, here we go. This is what your ignition system should look like that's going on in your combustion chamber. All right, now what we're going to do is I'm going to first deactivate this so that I don't zap myself. And we're going to take this here piece and isolate that. Now what this is simulating is if the engine block is not grounded well. Let me stand here so you can see it this way. The engine block is not grounded well because you have a foam insulator between you and the frame. So as if you have a loose ground or a bunch of paint between your bolts and brackets, or even way too small a ground, this is what you're simulating here. All right? Let's see, hook this back up. Woo! Get in tight on it so they can see it. Look at the difference in your spark. Are you zoomed in close? Everybody see the difference? It's firing. The engine will run, but it's nothing like before. And so what happens? Well, when you're doing high compression engines or throwing a bunch of fuel to it or trying to turn 8,000 and 9,000 RPMs or even 7,000 or even less than that, the engine will break up, it will misfire, it's not going to be smooth, you're going to have poor acceleration, and all because of grounding issues. So it pays for you to pay attention to little things like that. Why spend all that money on the best engine money can buy, but yet your race car is not wired correctly, or you just have poor grounds? Just because, I'll tell you, like for example, when we set all the land speed records, we set over 20 land speed records, and a company called Rod Crafters out of Welcome, North Carolina, they actually built both cars. And the first thing that happened was once we got the engines installed in the car, I actually built all the engines, and they installed them for me. And once the engines were put in the car, we had running problems with all of them because it was more than one. It was actually like 3 or 4 we set. And each and every time they were putting the grounds over top of powder coat. And it really hurt their feelings when I went in there with a grinder and ground that beautiful show quality race car powder coat off the frame. But when he hit the gas pedal, it was a whole different story. So you just got to, you got to have your grounds. It's very, very important. Save yourself the heartache. You've got all this time invested in the car, all this time invested in the engine and chassis setups and tires, and you know, time that you can't get back that you've worked on that car. So don't skip the wiring. The grounding is so critical. It is so critical. Anyways, hope you learned something. So stay tuned for more. I'm Brian Salter. Have a good day. All right, guys, so I'm smiling because at the 19-minute and 28-second mark, I got zapped. I mean, it came through the table, through the distributors, through the drill handle, and popped me. So that's why I was emphasizing these boxes with high amps are no joke. The reason it did that is because even though I had zero continuity, and you'll see the rest of the video, I did not grind all the mill scale off of that steel. And I'll show you what that looks like here. This, when they make this stuff, this is down on the bare metal. This is mill scale. It does not conduct electricity very well. So if you're going to ground to metal like this, make sure you get the scale off. So anyways, thank you for watching. Please subscribe. Enjoy the rest of the video. Have a great day.